So let's start by talking a little bit about some of the actual mathematical material that we're going to be going over in this course. So Calculus 4 is kind of a weird class in that we're starting over to some degree. The main topics in this class are differentiation, integration, and some things that look very basic from the point of view of what you've already done in Calculus 1 through 3. In particular, the things we're going to be doing are derivatives, maximization and minimization, Taylor polynomials, or integrals, change of variables, and kind of fundamental theorems of calculus. They sound very similar, but the main difference is that we're going to be doing these in 2 dimensions and 3 dimensions. And so what we're going to be dealing with for the majority of this course is just handling how geometry works and how geometry makes changes to the way things operate. So a couple of background pieces of information are appropriate to go over then. We're going to be talking in coordinates in 2 dimensions and 3 dimensions. When we do coordinates in 2D, we use a standard xy axis with x on the horizontal axis and y on the vertical axis like this. This is the way most people operate except for economists. In 3 dimensions, we're using what's called a right-handed coordinate system, where we have 3 axes, the x-axis going across, the y-axis going up, and the z-axis, which you can imagine is kind of coming out of the screen towards you. And this is called a right-handed coordinate system because if you hold up your right hand with your 3 fingers like so, the x-axis should be your thumb, the y-axis should be index finger, and the z-axis should be your middle finger. And sometimes left-handed people get annoyed about this, but it's actually easier as a left-handed person to use a right-handed coordinate system because then you don't have to put down your pen. So, like so. Now, the main topic in this class is going to be functions of several variables. Most of the functions in regular calculus that you deal with on a day-to-day basis have one input variable and one output variable. And that's nice, but it doesn't reflect almost any actual real-world system. And so we can usually have functions that have one input and several outputs, or several outputs that feed into one input. And so those types of functions are what we're going to be considering. We have to be able to interpret them, talk about their interpretation in terms of rates of change. We have to talk about different ways that we can think about them. So for a function that has several inputs and several outputs, there's going to be several different ways that we could think of what that function is doing and what we're going to be using it to express. And so mainly, the thing that is going to be difficult in this class is dealing with the underlying geometry of all of these situations and figuring out exactly how we can think about them, how we can reason with them, and how we can get through it.